Welcome back to Summarize Science. Our galaxy is haunted by ghosts, not spooky spirits, but vast, faint rivers of stars called stellar streams. These streams are incredibly delicate, and astronomers are now using them as cosmic crime scenes to hunt for the universe's most elusive substance, dark matter. A new paper looks at one stream in particular, called GD1, to see what has been disturbing its ghostly trail. Stellar streams are the shredded remains of smaller star clusters or dwarf galaxies that were torn apart by the Milky Way's gravity. You can think of them like a trail of breadcrumbs, perfectly tracing the path of the object that was destroyed. In a perfectly smooth galaxy, this trail should be neat, orderly, and kinematically cold, meaning all the stars are moving together at very similar speeds. But when researchers measured the stars in the GD1 stream, they found something surprising. As you can see in the bottom panel of this figure, the stars are much more shaken up than expected. This measurement, called velocity dispersion, is like taking the temperature of the stream, and GD1 is running a fever. In some parts, the star speeds vary by almost 5 kilometers per second, which is 4 times higher than any unperturbed model can explain. This tells us that something invisible has been repeatedly punching through the stream, giving the stars gravitational kicks. The primary suspects are invisible clumps of dark matter known as subhalos, which our standard theories predict should be buzzing all around the galaxy. To test this, the scientists ran millions of computer simulations, as shown here, pelting a virtual GD1 stream with different populations of dark matter clumps. They wanted to see what kind of dark matter population could create the exact amount of chaos they observed in the real stream. Their results provide a powerful confirmation of our standard cosmological model. The researchers found that the stream's high temperature is perfectly explained if about 5% of the Milky Way's total mass is locked up in these dark matter subhalos. This number is right in line with what the standard cold dark matter theory predicts. This plot shows their findings, the blue shaded areas, fitting beautifully with other measurements, and the red line representing the standard theory. But there's a fascinating twist that could point to new physics. The data suggests that to create the observed disturbance, the dark matter clumps might need to be more compact and dense than the standard theory expects. This could be a hint that dark matter isn't just a simple, non-interacting particle, but might have its own complex behaviors. So to recap, scientists have used the GD1 stellar stream as a giant gravitational detector. They found that its stars are moving far too erratically for it to exist in a smooth galaxy. This heat is caused by invisible clumps of dark matter, and the total amount of these clumps matches our leading theory. However, the clumps might be denser than predicted, opening up exciting new questions about the fundamental nature of dark matter. In the future, astronomers will apply this technique to the dozens of other stellar streams now being discovered. Each one is a new probe, helping us to build a complete map of the dark matter scaffolding that holds our galaxy together.